Hey YouTubers, okay, we're going to work on this 5/8 wave antenna, and I'm going to step you through some things that I learned, and I'll show you some things that you need to know. Wire length, okay, make sure you got the right wire length. Making an inductor, okay, because this is 5/8 wave. So let me stop there for a minute. If you're here and you're learning to make antennas, okay, and you want to make a 5/8 wave antenna, you have to make a circuit, okay, something to change the resonance. If you're here watching and you think you're making an antenna for half wave or quarter wave, it's not going to work, okay. The 5/8 wave is different. Let me show you. This is 50 ohm right here, coax coming in, okay. It's running straight through to our antenna hookup for our wire, okay. Now this is a ground mounted, but I'll explain how to, if you're going to go vertical with it up in the air, the only thing you got to change. So if you're looking for a ground mounted 5/8 wave antenna, then this is what you should be watching. If you're going for a half wave antenna or a quarter wave antenna, you don't need to do this circuit stuff, okay. You can just hook directly to your coax, 50 ohm coax, and run it straight through, and you're good to go, okay. You don't need to watch the rest of the video. So if you're quarter wave antenna or a half wave antenna, you can go directly to your 50 ohm coax and no problems, okay. So there you go. Now you don't have to watch the whole video if you're confused. If you need to know your length of an antenna, quarter wave or a half wave, you just measure it out. A half of the 10 meter is 5 meters, okay. And if you're dealing with that, then you're on a separate than what I'm going to show you, okay. You can just stick with the 50 ohm coax directly in, and you're good to go. You don't have to watch the rest. But if you want to make 5/8 wave, I'm going to show you how to do that. It's called a circuit, an LC circuit, okay. There you go, okay. Same thing, ground mounted, all right. We're going to hook this to our ground plate, right. We're just going to set this one on top of our ground plate and hook our ground here instead of actually it being hooked right here, okay. Just some different styles that I can show you. You could even use this. This is an old 9-to-1 Ballon or whatever. If I got Chinese Ballon, I just ripped that stuff out of there. It's junk. And run a household wire straight through. Now this is 50 ohm, okay? This is strictly for quarter wave or half wave, okay? I'm just using this to show you, okay, what you can do, okay? This is what we're gonna be working on right here, okay? In order to get to your 5/8 wave, I'm gonna just cut to the chase right here. Most of them online calculators are junk. That MMNA software is not too bad. It'll kind of help you with your circuit, your LC circuit, and I'll explain what that is. But what you're gonna need to know really is wire length. Start out longer than what you think. I'm making this for 10 meter, okay. You can make a 12 meter, 17 meter, a 20 meter even. But I'm not kidding around with you guys. You're going that length, you better have you a tower or a big tree because this is some long wire, okay. Just at 10 meters, I'm at 24 feet, okay. 24 feet on a ground mounted, okay. Now, my setup's a little different than like a DX Commander, but it's the same style, okay? But that's what I'm building for you today. If you're gonna go true vertical with this, you'll need this circuit right here, but you'll have to tune your radials, okay? They'll have to match the length out here on your radials, where you hook your radials to, all right? You'll have to match that across for your height, okay. So that's going to be different if you're going up in the air with it. If you're going to stick it on the ground, ground mounted like a DX Commander style, you can do just what I'm doing right here and it'll work. You'll work fine. I wanted to show you the innards of the box, okay? So you can see we got our ground right here running over to our PL259, SO239, whatever you want to call it. This is where our 50 ohm coax comes in, right? And I said, oh, you can't do that. You can't hook 50 ohms to a 5/8. Well, I'm going to show you. You can. All right. So we're running our coax in here. We're pulling our ground over here, okay? And what we're going to do is right here is where if you're going to go vertical, up in the air with it, then you got to tune these radials. You got to get your radials out, and you got to tune them the same length as your wire. And they'll probably be a little bit shorter, but I didn't make a vertical. It's too dang tall for where I'm at. So I'm sticking with the ground mounted. You can see this other post is the center conductor of our 50 ohm coax. Okay, it comes straight through, and then we're going to hit our inductor, and that's what we're going to talk about next. Okay, and inductors. When you're making one of these, the software sucks for the length, guys. You'll waste wire. You'll be too short. Okay. I don't know what those calculators, how they work, but I've made 2 of these so far, and every one of them's been longer than what it said. Half of a 5/8 wave, if you measure it out, a 5/8 wave on 10 meter is 20.5 something feet. Okay, my antenna is 24 feet. So there is a big discrepancy there between the lengths of what the softwares online are telling you. Now that may be for a vertical that's in the air, and that's what they're telling you. But both of mine that I made so far have been longer, okay, than that. Now you can make it shorter, but what you're going to do is put more turns in your circuit here. Okay, this is just an inductor, is all it is, guys. All right. And then this is going to be our capacitor. Just some 75 ohm coax. You can use 50 ohm coax. Just something that has capacitance to it. And I'll show you how to hook it up. All right. But to make your inductor, a lot of guys think, oh man, you got to have those calculators, know exactly how many turns. Now. Look, I made this one up just to test. I just wrapped it around a socket. Okay. It has too many turns in it. All right. I could have just cut it off right there and then made a new post sticking out here, or off there, and it probably would have tuned in. But I wanted to make something a little nicer because this thing kind of flops around. And if you move these in a certain way, you can move your standing wave a little bit. It didn't help mine. It actually harmed it. But I like this stiffer wire. This is house wire. Okay, right here I made a little one, a little short one. Now this one's bigger, okay, than this the one in here. See, you can see it's smaller. Okay, the only difference is you just need more wraps. Okay, that's all you need. You just need more wraps. The more wraps you have, though, it's going to take a little bit of power away. The more wraps you have, the more power it's going to take away. Well, I cut my 10 meter wire at 20.5, or what was it, 22 feet. I thought, well, I'll take a little bit longer. And it was too short. So I needed more wraps on my inductor here, okay? That's all it is an inductor. I needed more wraps on that. Well, the dang thing was that long. Well, that's going to steal a lot of power, right? Anytime you put a coil or an inductor in anywhere in your transmission line, if it's not running straight through, that's running straight through. See? Yeah, I'm not losing nothing. But anytime you put a coil, capacitor, anything in that hot side going through, you're going to steal some power, okay? Just to let you know that. So I want my inductor kind of short, so I want to make my antenna a little longer. The antenna's an inductor too, guys. So really, you're just adding more inductance and capacitance, okay? And I'll show you how to do that. But if you're wondering, oh man, how do I know how many wraps and whatever, right? Okay, it's easy. Just get you a socket, Just a little old, socket out of the toolbox there. I think this one was 16 millimeter. I used a 13 millimeter for this. I think I used a 15 millimeter for this. This one and this one are the same. That if I took this one out, put this one in, it works the same. It's in the same spot on the on your SWR. Okay, doesn't move the antenna. All right. The only difference is what I noticed is the standing wave changed. Okay, so the placement of where it was on the band changed. That's all it is. You're just moving that across the band until you get it right where you want to resonate, and then boom. Then that's whenever you want to start changing your capacitance. Okay, so let me go over this a little more for you. This inductor, it's just an inductor, guys. And when you hook a 5/8 wave wire, which is way longer than a half wave, your impedance is off. It's going to be off. Okay. Instead of being at 50 ohm, you're like at 110 or something, I think is what mine was showing. So you got to get that down to 50 ohms in order. And what I'm talking about is on your standing wave, on your nano VNA or your whatever. Okay, you got your frequency range here, right? This is 26 megahertz, right? And let's say this is 29 megahertz. Okay, this inductor right here, all you're doing is moving that across that band. You're changing the length of the antenna, is all you're doing. Just right here. Instead of actually cutting the wire and making the wire shorter, okay, you just by changing it from this right here to this, all it did was moved it. Okay, so and where we want to be, down here, okay, right here, that's where we want to be. I don't know if you can see that, but you see, all it was doing was moving that left or right, left or right, left or right. When you get it close, you'll know. So if you're trying to build one of these without a nano VNA or an antenna analyzer, forget it. Each antenna is going to be different. The capacitance of how many ground radios you have is going to be different. So all that's going to change. So all you're doing with this inductor, this little coil, is moving it across the band. You're finding out where it's at first, and then you got to say, okay, I need to add more wraps, or I need to take away wraps. That's all you're doing, adding or subtracting, just to move that spike, down into the range of the frequency you want. Okay. Now you have to do this, guys, because it's 5/8 wave. It's bigger than a half wave, and it changes the impedance on the coax. Okay, that's all. Now for you, some guys, okay, you're not gonna have, if you got 10 radials down, right, you don't even, 10 radials is 10 radials. I'm not gonna go with quarter wave, half wave, like all that crap. You put 10 radials down, they could be 5 feet, they could be 2 inches. Okay, it's gonna work. Something's gonna happen. Okay, so but here's where the key is on your radios, guys, on your ground radios. You're gonna hook your ground. I use an oven pan. Okay, you're gonna hook that underneath and connect it to your ground, and then all your radios are gonna come out from there, right? So if my little square oven pan, okay, my 9x12 oven pan, and I got like radios coming all off here, right? I got 137. That's a lot, guys. Well, that's a lot of capacitance, okay? Now, you may only have 10, okay? You may be the guy in the backyard that's only got like 10 radios, right? Okay? That's not a lot of capacitance, okay? So what this LC circuit is, all right, and I'm not going to write that down or nothing. I don't want to bore you guys. This is the L in your LC circuit for your 5/8 wave antenna. Right here, this little coil, okay? That's an inductor. That stands for an inductor, okay? Your capacitance, and we're just going to use a piece of coax, okay? your capacitance, right? If you don't have a lot of ground radials, you're going to need this. I've got a lot of ground radials, and they're permanent, they're set. So my antenna personally only needed this. That's it. My 5/8 wave antenna only needed this little bitty inductor going, and she's rocking and rolling. I had this in there, and I'll show you where it goes and how to hook it up. Okay, but I had this in mind, and my antenna didn't need it. It basically drove the standing wave up to like 1.2, and I couldn't get it to come down. I was like, what in the world? So I kept cutting away. Finally, I was down to this much. I had like that much. I was like, man, this thing ain't doing nothing. So I just clipped it out of mine. And sure enough, my standing wave went from a 1.2, right, the lowest I could get it, all the way down to a 1.03. So it narrowed her down on the spectrum analyzer, okay? Big time. And man, did it come alive. It's got a receive like you wouldn't believe. Low noise, and it's high Q, to be honest. But I need to show you where this goes. How you hook your capacitance into that inline circuit right there, right? I did this. I used the braid as the capacitor. Okay, that's wrapped around there. I use that braid right here, this connection, as the capacitor. So I hooked this solid piece, the solid connector, or solid piece of wire, to the ground. Okay, so I went like this, right there. And that was my circuit, okay? And when you put that in line right there, you're going to see probably a big difference in your standing wave, okay? Now, all you got to do to tune it, guys, you're not going to tune this. You just want to tune your antenna to get it where you want. You just start cutting your inductor down. I made mine longer. It was about that long. All right, I just kept cutting it down until it moved the frequency for the length of my antenna, for the length of my wire. Okay, so let me state here, and I'm going to set that on there so you can see how it actually goes together. Right there's your circuit. Okay, that's how it solders together, guys. And that's all it was. Okay. Now you're thinking, oh man, this is confusing. It's not. It's really not. So, I mean, you're just going, basically you're putting this braid in with this inductor, and it creates capacitance and moves the standing wave of the antenna up and down. Your capacitance will move it up and down. Okay. Right here. If you start cutting that, cut it down, right? So you may be way up there. You start pulling capacitance down, and what'll happen is on your VNA or you'll start seeing that standing wave come from up here all the way down. It'll start dropping just by cutting that out, shortening this. Okay, to move the antenna, okay, keep your wire at one length. Okay, so my pole that I put together for my antenna is exactly 24 feet tall. My wire is 23 6". Okay, somewhere in there, 23 6 4, I don't know, somewhere in there. But it's 23 feet, 6 inches or so. And what I did, I left about 6 inches at the top of it. And I can show you, I'll take you outside and show you the picture. But stick with one length of wire and use this, okay, to tune it, okay? So it may be this long, you know, compared when you start out, okay? And it'll be way over here. And then you start tuning this, cutting this shorter and shorter and shorter, and you'll just start pulling it over and over this way towards where you want to go, okay? If you're way over here and you're trying to get to there, you're going to have to add length, okay? So then that's where your antenna comes in. You have to add length, okay? You don't want to add it here. You want to take away from here. If you add it here, you're going to take away power, okay? Is all you're going to do. So make it longer, make your wire longer, and then tune with this right here. And then when you get it in tune, then you can tune your standing wave here on your capacitor and bring your standing wave down this way, okay? And then what you'll see after you're done, instead of it being up here, right, it'll look like this. And that's what you want. That's what you want. You want to get way down there. You don't want to be up here. You want to be down here. So this right here, your inductor, and you can see how it's all hooked up. Okay. I didn't hook this side up just to show you though. I just set it there. It goes to your positive of your antenna wire. Okay. Grab your antenna wire. Goes there. And that is basically your whole circuit right there. And you can move this, guys, around, okay? You can make you a longer ground wire come up and set this over here like so or whatever, however you want to do it. You can put it on this side or you can put it on this side of the wire. But you got to get that center one to ground. So really how you design your box or how you design your thing here is going to be pretty much dependent on where you mount your capacitor, okay? So remember, if you guys are half quarter wave or half wave antenna, you can go straight through, okay? Straight through. Ground is the ground is here now, so ground on this one is right here. But if you want to go a quarter wave antenna or half wave antenna, you go with this bad boy, okay? You go straight through. You'll be fine. If you need a 5/8 wave and you want to get up in that better receive and you get that higher gain, I think mine's showing about 7.2 dB gain. And the reason why it's higher, most of them are only about 5 to 6 dB gain, okay? The reason why mine's higher is my wire's longer. It's longer than an actual 5/8 wave. It's, I don't know, I'm up there, 3 foot longer. So I'm getting more dB gain from it. And you can tell, I can tell just by transmitting on FT8 and Whisper. And but I wanted to go through this with you guys on the how to tune your circuit like this so that you can understand it a little better on what you're doing. Because I searched online and I found one video of a British guy, I think over there in the UK. He built a 5/8 wave, but his was vertical. His was up in the air, and he had to tune his radios. And that's the only difference. If you're ground mounted like this one, or like, this one, okay, ground mounted, right? You're just going real short to your radios. You don't need to tune them. You're just using it as capacitance. There's something in I can't remember it. After I got hit in the head, some of this stuff doesn't stick with me. It's called precession, and it depends on if you put something in between the inductor, if it changes it from a 1 or a 0 or whatever. But if you put an LC circuit just like this, right? You got your coax there and everything. So you want to solder this in, solder that to your center. As you can see, the center, and that's basically your circuit. You're getting that soldered in. Then you just clip off your capacitor right there to tune it, okay, to get your standing wave down. Okay, that's it. But if you use tuned radials, then that changes. I think those tuned radials will move this up or down, but it may move it to the side too. It's really weird if you're vertical, if you go in the air with it. But man, you're going up high. You better have a tall tree or tower or something if you're doing that. And that's why you don't see a lot of these 5/8 waves on 20 meters man, that thing's gonna be super long. You know, you're better off go with a sloper or inverted V or something. But for 10 meters and 11 meters, yeah, it's doable. So I did it from the ground. So um, let me pause here and I'll take you outside and show you mine and give you another close up of the circuit itself. But that's pretty much all it is. You tune that, right, to move it this way. You make that one shorter to make it go up or down. Okay, that's it. All right, hang on a minute. I'm gonna pause you, and we'll edit this in, and I'll show you mine outside. Okay, so there's mine, guys. There's my box. All my radials. That is so I can hold my wire up. It runs up the pole. But there's my actual wire. It's connected there. Comes up there. But all this blue wire does is go up to the top, way up there, and then I hooked a piece of pipe over it, and it's about 6 inches away, and got my tie downs. I'm gonna be honest, guys, the hardest part about making the whole antenna was getting the pole up in the air and working. But I just wanted you guys to see that. That's a little fishing reel handle, you know, spool, and I just put it on the end of the pipe. That's just stuck in the ground. That's just PVC pipe, 1.25 inches. That's 1.5 inch pipe going up to a painter's pole, and that's where the painter's pole starts. So there you go. That's mine. And well, anyway, guys, I hope that helps. Good luck to you if you're wanting to build a 5/8 wave, but it's worth it. You'll see. Have a good one, guys. And thanks, Dr. Jack.